It's awesome to see people are excited to meet Antoni, as I was when I met you first time.
I'm just a humble practitioner.
Yeah. Quite a bit of people already. Just we'll be waiting till 6:33, and then we'll start. So guys, meanwhile, why doesn't everyone write in the chat, their roles, what they are expecting from the session, and where they're from, so that we can have some kind of a context for Antoni about his audience, and he can contextualize a bit.
Folks, before we begin, just landing the rules for the session. Please keep your microphones on mute at all times. And if you have any question, we'll be opening up the windows shortly for the Q&A. Please feel free to type in your questions there, and then we'll be taking it up with Antoni in the Q&A slot later. Thanks.
Yeah.
Appreciate that.
All right, it's 6:33. Let's begin, Milind. Yeah, let's begin the session.
Yeah, sure. That's great. We have a flurry of participants joining in. Cool. Then. Good evening, ladies and gentlemen, and thanks for tuning into our first session for the Tech Jam that's organized by Sears. I am Milan, currently leading GTM for the West region. To give a short introduction on what we do, Sears is a modern tech consulting firm that empowers customers to futurify by leveraging cloud, AI, and analytics. With around 4,000 plus global clients and spread across 4 plus geographies, we are a Google Cloud Premier partner with expertise in core engineering capabilities. Not just that, we have also been recognized as Google Partner of the Year in the APAC region for last 5 consecutive years now. This also gives us an edge over the latest technological advancements in Google Cloud industry, basically, and the emphasis is always being on the, you know, engineering first organization since we operate under the hood of enterprises, corporates, and digital natives. Due to a strong customer first culture, we at Sears are constantly trying to solve for better, and we hope we are solving for better. Yes, in totality, we work with, by, and for our businesses to engage with them in the entire tech modernization cycle, ranging from, let's say, infra, application, and big data to analytics. Having said that, we look forward to our presence in more such sessions and tech bites in the future. We'll continue these series and the sessions in the coming weeks. I would now like to hand it over to Animesh Rastogi over here, who's my colleague and leads GTM for corporates. We are also joined in by our guest speaker, Antoni Tzavelas, who will shortly cast his magical spell, and then you'd start wondering who Harry Potter was. So, over to you, Animesh. Yeah.
Yeah, thank you so much, Milind, for that introduction of Sears. So let me set a bit of context for the session that we're undertaking. So the reason we are all gathered here is, of course, as you all read the title, it was pretty self-explanatory. But let me spend around 15 seconds giving you a bit of brief. So we all know it's a very big challenge, to start learning about DevOps. Every time you hear DevOps, you just get confused about the hundreds of tools, present in the market. So that's why we have someone like, Antoni, who's had a bit of experience in the IT industry and is a DevOps coach, to come and expand your knowledge horizons, and of course, give you a bit of understanding on how to get started with Google Cloud and DevOps and SRE. So yeah, we have Antoni. So for those of you who don't know Antoni, right, Antoni is a man of many hats, from technical architect, instructor, scrum master to a DevOps coach. He's also a man of many bow ties, which he wears to cheer people up. He started his professional journey in the fashion industry, and he absolutely loved it. But then, as fate would have it, he decided to reinvent himself in the IT industry as a Unix admin, which was his first role, which I guess lit the fire in his belly about cloud and DevOps and everything. And as of now, he has been in the IT industry for over 17 years, where he has worked in a plethora of different roles. And over the course of these 17 years, he noticed that the importance of humanity within the technology industry had started to diminish a bit. And this led to his mission and his purpose to bring the human element that he experienced in fashion back to the technology industry. No offense to all the ML and AI engineers, but and Antoni's current role is of a Scrum Master and a technical guide at his organization. And of course, also being a full-time Google Cloud community hero and a massive LinkedIn influencer. And for the students who are present on this call, he is also a guest lecturer at the University of Toronto. So without any further ado, here's Antoni for you guys. Antoni, go ahead.
Thank you so much for that that awesome intro, Animesh. And good morning, good afternoon, good evening to everyone here on the call. I'm honored and humbled to be here talking about one of my favorite subjects, which is DevOps and SRE. I'm going to go ahead and start the presentation.
Perfect. Yeah.
Okay. So, so I wanted to quickly set the context here. A lot of people do have a lot of different ideas about what DevOps and SRE are, and I wanted to really make it clear on what it is, how they differ, and how these different principles and mindsets can be applied. So I wanted to first start off with what is DevOps. So many people have different explanations. If you ask somebody what is DevOps, chances are you'll probably get a lot of different definitions. So, but I wanted to go back to the heart of DevOps through Jez Humble. So he's a well-known and respected figure in the DevOps community who describes DevOps as a cross-functional community of practice dedicated to the study of building, evolving, and operating rapidly changing, secure, resilient systems at scale. I know it's a mouthful. But in short, DevOps aims to shorten the system's development lifecycle and provides continuous delivery with high software quality. So, and as I go through this presentation, I'm sure that you'll start to understand as I start to break down the principles and methodologies, things will become a little bit more clear. So I wanted to get into a bit more context as it relates to what DevOps is by talking about the goals achieved by implementing DevOps. So the first one is that DevOps is designed to improve deployment frequency. So instead of deploying once a month, DevOps allows a higher deployment frequency. So instead of, again, once a month, you can now do a few times a month, and for some, a few times a day. So it also allows faster time to market, and sometimes can be the differentiator to being first to market. DevOps also implores lower failure rate of new releases through the use of automated testing and code being committed and validated prior to integration into the mainline branch. And due to deployment frequency and automated pipelines through a DevOps methodology, it allows shortened lead times between fixes, which also brings faster mean time to recovery and should lower exponentially as DevOps maturity grows within any type of organization. So now that I've gone through what is DevOps and the goals of DevOps, I wanted to talk a little bit about what DevOps is not. Now, there's a few myths that I wanted to point out, and so I wanted to be clear about it. So DevOps is not just development and operations teams. DevOps encapsulates many different teams within any organization, and it breaks down the silos within those departments. And that's the main goal there, to work collaboratively on the same mission. So DevOps is also not a separate team, a job title, or a specific person, nor is it a role or qualification. It's actually a culture shift and a mindset. And it's designed to bring better communication and collaboration between various teams while bringing quality software faster to market in a reliable manner. Now, there's no doubt that there's many tools out there that people use within DevOps or enable DevOps in an environment. Yet using a specific tool does not equate to DevOps. You know, I've heard many times people say, oh, I use Jenkins and therefore we're DevOps. That's really not the case. Tools are used as a conduit to bring better software, faster market, increase velocity. But again, it doesn't equate to DevOps. As well, adopting automation and tooling combined with CI/CD is a part of DevOps, but should never be confused with the mindset and culture shift of true DevOps. So now that we've discussed what DevOps is, what it's not, I wanted to give a little bit more context into life before DevOps. Now, before DevOps, different teams and departments were siloed and were structured to work as separate entities, with each of these departments having their own goals and responsibilities. And so this created a lack of communication and lack of transparency and constricting workflow. And this hindered the release of new software and software updates because of the lack of communication and transparency. Now, the old way of creating and maintaining software put separate departments to work on different parts of the project. But the real pain started with development and operations. So developers planned, designed, and built a system from the ground up, and then they passed it over to operations for testing, implementation, and integration with their existing systems. Now, there's often a long delay between development and full implementation because of the break between development and operations. So if something needed to be reworked or bug fixed, or if the software didn't meet the needs of the final user, operations had to pass it back over the metaphorical wall. And I'm sure you've heard this so many times. So when the software was ready to head into deployment for testing or production, it was passed back over to the wall, to, pick up the pieces if something was wrong. And so this created a lot of tension, and things didn't work quite the way we thought it would. So a common phrase that was heard was, well, it worked on my machine. I'm sure you've heard that many, many times, especially when it before containerized environments came about. Another common phrase was, it worked fine in dev, so it's ops problem now. And so this is because the environments weren't the same and they were missing key components. So either way, it was a battle that couldn't be won between developers and operations. And as I said before, it left them very, very frustrated. So adding to this frustration was the type of software development cycle that was used. So most software that was developed and updated were using what we call the waterfall methodology. And this is a traditional model for developing engineering systems and is originally based on manufacturing and construction industry projects. So when you apply this to software development, especially when it comes to specialized tasks, within each phase, it needs to be reviewed and verified before moving on to the next phase. So as you can see, the waterfall approach is a linear and sequential approach where phases flow downward to the next, hence the term waterfall. And so each subsequent phase can only proceed if the previous phase has been completed. And in between phases, a deliverable is expected or a document is signed off. Whether or not the phases pass through, you still have to continue through the flow. And because it's plan driven, any changes after the project that's started will require a complete restart, which means that a lot of money would be lost. So as you can see, this methodology is very restrictive. And because of this, newer development methodologies were created. So a few things I wanted to point out with regards to this methodology is that, again, linear and sequential approach, limited customer involvement, no allowance for uncertainty, rigid structure to allow necessary changes, and the list goes on. And this definitely did not work well for software development. Now, although the waterfall methodology is still used today, a better way came along, which allowed faster development and improved quality that development teams began adopting. So the Agile software development methodology, which is iterative rather than linear, focused on making smaller, more frequent updates to the application code base, and was designed to facilitate change and eliminate wasted processes. So the Agile methodology is a term-based approach, and it emphasizes rapid deployment of functional applications with a focus on customer satisfaction. And it's defined as a time box phase called the sprint, which I'm sure most of you have heard of, with a defined duration of usually 2 weeks, and sometimes can be up to 30 calendar days. So at the start of each sprint, a list of deliverables are prioritized based on customer input. And at the end of the sprint, the team and the customer review and evaluate the work that has been completed with notes for future sprints. Now, when put into perspective, many iterations in these specific short sprints can allow the project to be very flexible and won't need months to change course. And so the scope can be changed along with the development process at the end of each iteration. Now, there are 4 values that outline the principles of Agile that is referred to as the Agile Manifesto, which highlights the importance of people, product, feedback, and responses to change. So the first is individuals and interactions over process and tools. And this is about a strong communication and collaboration mindset that's built between team members across all functional domains and putting themselves and the interactions between them as the highest priority over the tools and processes. The second one is working software over comprehensive documentation. And this is about communications that take place while working together and likely to be effective between team members as opposed to writing the information in documentation. Now, since project requirements are constantly changing at such a fast pace, the third principle being customer collaboration over contract negotiation becomes a necessity to a successful project. Agile sees the customer as part of the implementation team and includes them in each part of the process, making sure that requirements are met after every iteration. And lastly, by using Agile, it has the ability to respond to change over following a plan. And you can achieve this with all available tasks in shorter periods of time, and can help both the vendor and the customer meet their collective goals without exceeding the project scope. Now, shown here is a graphical representation of how software is delivered and the differences in the delivery process between Waterfall, Agile, and DevOps. And as you can see, Agile can deliver at a much faster pace due to the small 2-week iteration periods. The practices of DevOps are developed based on the Agile principles, which is why DevOps delivers so much faster. Now, while using Agile practices, we know it can deliver software over a 2-week or 1-month period. DevOps takes us one step further and delivers software within a matter of hours, and like I said, can be delivered in a matter of minutes by using methods like continuous integration, continuous delivery, and continuous deployment, and is visually represented here in this diagram. Just a fun fact here, Amazon is actually known to deliver every 11 seconds. And this is due to the DevOps mindset that they have in place, and which is why they are the leaders in their space. Now, DevOps brings high quality and faster delivery between small and frequent deployments and fewer failure rates in production by combining and automating the work of software development and IT operations teams. And this is starting the benefits of DevOps. And organizations that embrace the DevOps culture see improvements in a lot of aspects of their software delivery process outside of the already mentioned. So things like improving communication and collaboration between teams, enhancing organization efficiency, productivity, and security, increasing velocity of the software releases, as well as maximizing customer satisfaction, delivering higher quality software, ensuring availability and reliability, thanks to faster and earlier threat and incident detection. And finally, promoting innovation, because we're now sharing ideas between teams. So shown here is the infinity symbol that we've all seen and shows a continuous flow throughout the whole cycle. And this is a common diagram you'll see across the internet, across documentation. And this represents the life cycle, sometimes called the continuous delivery pipeline. And it's shown in a series of iterative, automated development processes or workflows executed within a larger, automated, and iterative development lifecycle. And so, again, this is designed to optimize the rapid delivery of high-quality software, and is used in a lot of DevOps organizations. Again, starting from the left, continuous integration, moving it to continuous testing and continuous delivery, creating that continuous feedback loop. So I wanted to take a moment to discuss alternative DevOps workflows. So I'm sure that you've heard other terms that have been used with regards to DevOps, and they use they use a lot of the same principles of DevOps, but they focus more on specific areas. So what I mean by this is, I'm sure you've heard the term of Devsecops. And so this means building security into an application development from end to end. And so the purpose is to build on the mindset that everyone is responsible for security. In my point of view, security should always be built into your pipeline. I'm a firm believer of security being baked in and not bolted on. And so Devsecops covers that in full. And so I really think it's important to concentrate on security. And when you have a DevSecOps mindset, that's exactly where you're going to go at every single stage of the pipeline. Another workflow is MLOps. I'm sure you've heard of this because machine learning has started to become very big and very prevalent in the market. And so this is a set of practices that combines machine learning, data engineering, and DevOps. And this aims to deploy and maintain machine learning systems and pipelines in production, both reliably and efficiently. So no longer are we waiting for new data sets. We're continuously going through iterations of data and being able to come faster to market with new machine learning products. And the last workflow I wanted to touch on was Git Ops. And this is a set of practices to manage infrastructure and applications, mostly the configurations using an open source version control system. So Git Ops works by using Git as a single source of truth for declarative infrastructure and applications. A well-known concept and framework or workflow used with Kubernetes. And you'll see it very often, especially when using products that come from Weave. So here I wanted to take a moment to show you a DevSecOps pipeline architecture. Now, I wanted to show you this not just to show you what a pipeline looks like, but I wanted to really hone in on the products that are used. Now, although this is geared more towards Google Cloud, you can see that there are different products used here. And some of them are open source tools, some of them are paid tools, and you can mix and match and combine these different products to create your pipeline. So there's not any one specific way to build a pipeline. And that's what I really wanted to hone in on here. As you can see, the continuous integration with regards to the source code, the building and testing, as well as the artifact management. That's a continuous loop and can be used with different products. Going into continuous deployment, using configuration management tools as well as deployment tools, things can be done automated and then pushed out to whichever environment that you're currently looking to deploy on, whether it be development, QA, or prod. And finally, monitoring and testing using a slew of different products, being a paid tool like Datadog or open source tools like Prometheus. So the possibilities are endless, and it's really good to think about native tools versus open source versus paid. It all depends on what you're trying to achieve. So the goal of this slide was to mainly give you some thoughts about how to put together a pipeline. So not just using Jenkins, but to think about the pipeline from end to end using different tools as needed. Now, getting into one of my favorite drivers for DevOps is the comms framework. So comms is a conceptual framework for the integration of development and operations with functions and systems within an organization. So the comms framework is often used as a maturity model to help evaluate whether or not the organization is ready for DevOps, and if not, what needs to change. So the acronym comms was developed by Jez Humble, as I described earlier, and he used this to describe this framework. And so getting into the 5 pillars of the comms framework for DevOps, they're broken down into culture, automation, lean, monitoring, and sharing. And so I'm going to go into a little bit of detail just to give you a little bit more clarity, starting with culture. So with culture, teams can identify helpful practices to create a culture that fosters information flow and trust. So again, tearing down the silos, organizations are able to foster a culture of shared responsibility, and they're able to establish support in this culture with management approval and support. And in my opinion, this is the most important pillar in DevOps. Moving on to automation. This is the second pillar and is one of the major contributors to DevOps delivery methodology. It involves continuous integration, version control, continuous deployment, and continuous delivery. Moving on to the third pillar of DevOps is lean. Now, lean originated in the Japanese manufacturing industry, probably just after the Second World War, and focuses on improving cost, quality, and delivery time by removing waste from processes. So later in 2001, a group of software development professionals felt it was time to break away from the traditional approach and put the focus on individuals working products and services, customer collaboration, and responding to change. So in addition to this shift, technological improvements meant that consumers were more likely to be part of the project by providing feedback and interacting in real time with different teams. So this change caused lean and agile practices to be embraced by the community, which in turn led to exponential growth in project management effectiveness. So the DevOps methodology grew out of a combination of lean and agile principles. And so again, the essence of lean is to deliver value to the customer and to continuously improve the ability to deliver value by removing that waste. So wasted processes by logging into servers manually. I mean, nobody really needs to do that, which is why there are better processes out there. And again, lean is based on 5 principles: value, value stream, flow, pull, and perfection. I can spend a lot of time talking about lean, but I'm going to continue on into the 4th pillar, which is monitoring. And this is the process of collecting, analyzing, and using information to track applications and infrastructure in order to guide business decisions. So monitoring gives you insight into your systems and your work, as well as providing rapid feedback. So you can quickly find and fix problems early on in the software development cycle. It also helps communicate information about your systems to people in other areas of the software development and delivery pipeline, as well as other parts of the business. And finally, moving on to the last pillar, and the 5th pillar is sharing. And sharing works extremely well when there is an abundance of effective communication. So as I always like to say, sharing is caring with DevOps. So again, effective communication, excessive meetings or emails, very unnecessary, which is why communication tools like Teams or Slack is a better way to communicate. Or even just, unfortunately, due to COVID, we can't do this, but in the old days, I used to love just walking in people's desk and having a chat. That's a great way for effective communication. Again, touching on shared goals. So sharing responsibilities between environments and workflows. and eliminating that irreplaceable mindset. So what I call the lone cowboy, which is hoarding all that information so that they have job security. This is no longer the case. It was shown that sharing is a lot more productive than keeping that information to yourself. As well as taking time to listen to others and understanding, which brings a lens of empathy. And finally, again, the iteration cycle. So sharing through Agile and giving fast feedback. So now that I've touched on DevOps, I wanted to touch on SRE and give you an understanding of what SRE is. So the best way to describe it is SRE is a set of principles and practices that incorporates aspects of software engineering and applies them to infrastructure and operations problems. So in short, SRE is what you get when you treat operations as if it's a software problem. And this was something that was come up by a man by the name of Ben Traynor, who actually developed SRE for Google. SRE started at Google. It was their secret sauce to how they developed their software. And then they decided to share it with the world so that other people can be better at what it is that they're doing. So again, using engineers with software development backgrounds to perform work done by an operations team. So now that I've discussed what is SRE, I wanted to go into the goals of SRE. So the main goal is to create scalable and highly reliable software systems, hence the term SRE, software reliability engineering. So, and it comes from the mindset that no system is going to be 100%. There's always going to be failures, and so we always have to look and account for those failures. So the goal of SRE is to have the responsibility for the availability, the latency, performance, efficiency. As you can see, there's so many. But again, it all comes down to the reliability of your systems. So now I wanted to touch on the principles of SRE. So what makes SRE what it is? And Google has broken this down into a free documentation, and I'd be willing to share that with the rest of you after this presentation, or I can share it with the people at Sre, and they can distribute it at your leisure. So the first one I wanted to touch on is embracing risk. And this means weighing the costs of improving reliability and the impact it has on customer satisfaction. So as I said before, no service can ever be 100% reliable. So it's about improving the reliability, whether it be within the systems that we're talking about. So embracing risk allows you to know when this cost is unnecessary and could be better spent. Costs, whether it be money, time, or energy. So not overspending on reliability allows you to increase deployment velocity. And so embracing risk actually covers a cultural component. And this is due to people being psychologically safe in their work. So when you choose to embrace risk, your team should have the security to take advantage of these opportunities and know that in cases of failure, that all teammates had the best intentions, what it is that they were doing. So that way they're not scolded or penalized in any way. Another principle is service level objectives. Now, again, this is a topic that can be discussed in depth for for a long time. But I mainly wanted to touch on three things, which is the SLOs, SLAs, and SLIs. So SLA, which is a service level agreement, which I'm sure many have heard of. These are the commitments and the agreements that you make with your customers. And when it comes to these service level objectives, these are the goals that need to be met in order to meet the SLAs. And then the service level indicators, or the SLIs, measure the compliance with an SLO, so the actuals. And these translate into customer satisfaction, into an actual internal goal. And so they help manage risk and budget for error. So having those error budgets are, again, a major play in what SRE is. So eliminating toil. A lot of people don't understand this, and I really wanted to break this down. Eliminating toil means reducing the amount of repetitive work a team must do. So eliminating toil, you free up energy and time for other tasks. You also increase morale. So sitting there installing patches and uninstalling patches manually, it's not really a good use of time for anyone. As well, things like that can be automated. So it's also about finding steps in the process that are redundant or necessary and automating them. And so this is reducing toil, and this, again, can be documented and shown for new people coming on board or people that aren't familiar with the service at all. Another principle is monitoring. Again, it's basically the same principle as DevOps, where you look at the system and give you a better understanding of how it works and making decisions based on it, whether it be latency, traffic, error rates, saturation points. These are common metrics that focus on reliability. Another principle is automation. Again, this goes back to exactly what I was talking about in DevOps. It helps free up time for higher value work, and it helps deployment speed as well. So velocity increases as you apply more automation. And it can help in a lot of different areas of work, whether it be testing, deployment, incident response using automated runbooks, as well as communication. It can, spin up collaboration channels in Slack. Another principle is release engineering. And this is all about building and deploying software in a consistent, stable, repeatable way. So it applies SRE principles to releasing software, and qualities of good release engineering are things like configuration management, process documentation, automation, rapid deployment, and of course, testing. And the last principle I wanted to touch on is simplicity. And this is where developing the least complex systems that still perform the task that it's intended to. So the goals of simplicity and reliability go hand in hand. And a simpler system is also easier to monitor, repair, and improve. And so this is a holistic end-to-end approach of reliability and the principles of SRE. Now, when it comes to SRE best practices, we're talking about very similar to DevOps, with regards to blameless culture. So always assuming that there's best intentions and finding systematic causes together. So blameless postmortems. Celebrate failure, because it's an actual learning. And through retrospectives, you can take those learnings and apply them to the next possible failure, or even instead of looking at it as a failure, you can look at putting systems in place so that there is no failure. With SRE, there is such thing as on-call. For those of you who have been around for a long time, I'm sure that you've experienced on-call schedules like I have. But in SRE, there are on-call schedules, and best practice is to be empathetic and fair. So it's not about giving all the on-call schedules to the most juniors so that way they can learn more. It's about being fair across the board, especially when it comes to evenings and weekends and on holidays. So treating reliability as a feature. So putting your reliability goals in specifications right from the start, as well as sharing information, as we discussed before, and building an SRE team that works in roles from code development to spreading cultural values. And lastly, creating a culture that reinforces these principles of SRE. So it's not just about the SRE team per se, but it's creating the full culture around the organization. So now that I've discussed both DevOps and SRE, you're probably wondering, how do they differ and how do they work together? Well, I see them as close cousins. I see it as DevOps is the what, as the SRE is to the how. So the SRE is a mindset that is a spin-off of DevOps, if you will, where DevOps principles focus on software release and the SRE principles focus on software reliability. And so the things that they have in common is reducing the organizational silos. So breaking down those silos and again, focusing on collaboration and communication, accepting failure as normal. So there is going to be failure. It's a matter of how do we deal with it. Implementing changes fast and efficiently. So again, looking more at automation and putting the necessary principles and tasks in place to so that you're able to increase deployment frequency. And again, leveraging tooling and automation go hand in hand with deployment velocity. And again, it can be any type of tool. It doesn't have to be anything specific. So how do we make DevOps and SRE possible? Well, in my opinion, it's all about continuous learning, and an easy way to find a learning path is through certifications. Those who know me know that I'm a big fan of certifications, not because it's some clout, if you will, that you can put up on LinkedIn saying, hey, I got my latest certification. No, it's about the journey. So the learning path to getting to the certification. The certification is merely a milestone. So looking at Linux certifications, understanding the command line, bash scripting, Python scripting, and moving into the cloud platforms after that. So for me, it's Google and AWS, and I'm sure there are others out there who enjoy working in Azure or Oracle Cloud. And so understanding the context of the platform that you're working in and being able to architect it properly, as well as looking into tooling after that. So using things like Terraform for infrastructure as code, or Vault for secrets management, as well as configuration management tools like Ansible. And so moving from left to right, you can see that there is a track for continuous learning and a great learning path. And so I wanted to finally close out certifications. If you're looking for any Google Cloud certification prep, I do have a bunch of courses over at training.antoniT.com where you can learn more about not just the certification itself, but the topics that dive deep into DevOps, Kubernetes, GKE, as well as other products on the platform. And so with that being said, that finishes my presentation.
Thanks for that.
Thank you so much, Anthony.
Anthony.
Yeah, thank you so much.
Beautiful presentation, Anthony. It definitely helped us engaging what DevOps is, how DevOps is, and what are the spin-offs of DevOps, right? Now I'm pretty much convinced that Anthony, DevOps, and SRE are close cousins. So thanks for that, Anthony.
Yes, they are.
Yeah, definitely. Anthony, we have a couple of interesting questions for you, and I don't think we have the time to gauge all the questions, but a couple of them for sure. Let's start with one of the straightforward questions. What is the difference between site reliability engineer and system reliability engineer?
Ooh, that's a great question. I'll be honest, I don't know the answer to that. I haven't dug deep enough into SRE in order to fully understand that. But whoever asked that question, I'd be more than happy to do the necessary research and give you the answer that you are looking for.
Thanks for that, Anthony. Moving on to another question that says, let's say there's an organization and they strategically decide to move to DevOps. How do they actually ensure successful adoption of the same?
So successful adoption of DevOps should not only start within the team, but it should also start from the top, from the C-level executives. And there has to be a complete buy-in. It can't be, oh, we're just going to try, doing some automated testing and we're going to go from there. It needs to be a complete buy-in. So not only adopting just the automation monitoring piece, things that has to do with the systems, but it's about the culture aspect. And I find that a lot of organizations fail to deliver true DevOps because they are missing that culture piece. So I truly believe that if you apply the culture, everything else will fall into place because you have that understanding from everyone in the organization, and they're always looking at how to improve, continuous learning, and sharing of this through like brown bags or lunch and learns, and really starting to get the organization thinking and being innovative about how they want to do things. I hope that answers your question.
Absolutely, Anthony. Anthony, just last one, and I think we can then proceed with the closure note. It's an interesting one, and it's a bit on the personal level. What's your favorite DevOps tool and why?
Oh, man. So back when I was a DevOps engineer, I used to do what they call now click ops, and that is going into the console and clicking on what you need to deploy it. So when I discovered Terraform, my world changed. So because I've been in this industry for a long time, I have racked and stacked in a data center, and moving from waiting 8 months to deploy an application because you have to order the server, it has to go to the data center, you have to rack it, you have to cable it, you have to put it on the operating system, hook it up to the to the disk array and do all the necessities that you need in order to get this application up and running, to now being able to use a declarative language in a file that can deploy your whole data center. It changed my world. And so to me, that was a huge aha moment, seeing how fast you can now deploy and, the reasons for using infrastructure as code. I don't see why anyone shouldn't use infrastructure as code. I mean, if you aren't, or your organization is not, you're doing yourself an incredible disservice. So yeah, Terraform is my go-to. I think that every engineer and architect should learn it, at least at a high level, just to understand the upsides to infrastructure as code and why we should be using it.
Plus one to that, Anthony. Yeah, I think we all agree to that on the call. Uh, Thanks once again, Anthony, for taking up this session of the Tech Jam series. Definitely, it couldn't have been a better. There couldn't have been a better start to this.
Thank
Yeah.
you.
We also have Anshuman on the call, who leads this year's business in south of India and also in the east region of United States. Anshuman, do you want to quickly
Yeah,
give some
yeah,
closing thoughts?
yeah. Firstly, thanks a lot, Anthony, for all the time. I believe it's been like really amazing, especially to know about DevOps, as now it's kind of become a necessity more than a good to have. So
Yes.
100% a topic worth knowing about. And like on top of DevOps, the Devsecops, MLOps, Git Ops has been like an eye opener for me. So that should definitely help me in having more deeper conversations with our customers and the CALMS framework. So these are a couple of takeaways that I really would be diving deeper into. And
Awesome.
I would also like quickly want to thank Animation Milan for putting this up. As Milan rightly said, couldn't have had a better start to the Tech Jam series, and with so many people still on the call, we did something right today. So
Well, I'm
really
glad
great.
everyone enjoyed the session. There's one question in the comments that I did want to answer though. Google Cloud or AWS? So I'm a firm believer in using the right tool for the job. So if you are looking for a building block approach, something like Lego, then AWS may be your better bet. If you're looking for a platform that is more focused on integrated services, or when you're diving into data-driven services like BigQuery or any data warehousing or machine learning models, Google is always hands down the best in the market. So I hope that answers your question.
It does, absolutely. We were trying to refrain from it, but better coming from you than us. So,
I mean, my first love is AWS. That's where I first started, and so there's nothing wrong with Azure either. It's just using the right tool for the job. So it's not about picking a specific platform. I mean, my love is with Google, because that's just me.
I think
It's what I've worked with for the past few years. So
analogy, I think, really sticks of the Lego one. If you wanna modularize, I think GCP is better, but off the block integrations are better at AWS. I think we're top of the hour. Once again, thank you, Anthony, for taking out the time. And
no problem.
we will be creating assets and medias of communication so that people can reach out to you either via us or directly. And keep rocking on LinkedIn so we can keep on following you. And stay in touch.
Yes. If anyone has any questions or wants to reach out to me for guidance in certifications or learning paths, even a career path, feel free to reach out to me. I'm an approachable guy. I'm not going to snuff you. So If I don't answer you right away, it just means I'm busy, but I always get back to my people. You know, my community means a lot to me. And so I really take the time to give the love back.
Yeah. Awesome.
Thanks, Antoni.
Thank you so much, Anthony. And I second that point by Anthony, that he's one of the most approachable persons that people that I've ever met. And given, you know, a person at his position, that's an awesome quality to have. So thank you so much, Anthony. And I believe everyone is, you know, then now thanking you. And yeah, thank you so much. Thanks everyone for joining. Really appreciate it.
Thanks again, everyone. Really appreciate
Thanks, Antoni. Thanks, Antoni.
Bye-bye.
Thank you.
Bye-bye.
Thank you, guys. Have a blessed evening.
You as well.